clicker game works great, but still 0 in Autolab. I mean, if it works great, go to the interview, and if the demo works fine, I always look at those cases. If the demo works fine, but you don't have credit in Autolab, I look into your code, and if it's just some silly error, I give you credit for it anyway. So as long as it's working great, and you know that it's, you actually checked all the specs and know that when you play the game, it works perfectly fine, just go into that interview and demo it to the TA. I wouldn't even mention Autolab, because I'll look at it when I process everything, when I do the final grading. It is the easiest homework. It's the easiest homework if you're comfortable with JSON. But the JSON makes it pretty tricky. And it sounds like the hardest homework. Like when I introduced it, I spent a whole lecture talking about all the structure that's provided. But since it is all provided for you, if you just follow the steps of the assignment, it's not too bad. I agree with that. But once you get to the JSON, that's what trips a lot of students up here. Or if they completely don't understand actors and web servers, socket servers, which is, of course, the point. Yeah, I don't believe in a linear difficulty curve. Do it small. I don't believe that each homework should be harder than the previous one. I think they should all be roughly equal difficulty. They might seem harder as you go because I'm relying on your understanding of the previous learning objectives. Like if you don't understand OOP, you get to the JSON part of this AO5 and you get jammed up. So sometimes they seem harder because they're somewhat cumulative, but you're also becoming a lot better developer. You're getting a lot better at programming in general. I didn't realize how much I cover in one lecture. This used to be 2 lectures, but then once I stopped making it required, I'm like, well, I can rip through this content a lot faster now. What did I just do? Did I download it twice? And there's still a few mentions in these slides about projects. Oh, just to make sure, because I got this question a few times after Monday's lecture, there are links at the bottom for project contribution and homework expansions. Use those 2 links. If you have any questions about those things, click those links. For project contribution, that links to the doc that has all the information that you need about it, and also watch Monday's lecture, of course. And then homework expansion, that link gives you a form of how to inform me that you've completed one of your homework expansions. So if you did homework expansions, click that form, and then when I find the time, I'll go through and process them. And you'll either get your grades or get some contact from me. This one. Let's talk about GUIs. Actually, let me take a look here. Can't use MySQL in the Windows device. If you have to install MySQL. If you haven't installed it yet, it won't work. You have to install it and make sure the password matches the password in your code. Are all AO1 updated? I believe so. I don't think there's anything left for AO1. We already had interviews, makeup interviews, deadline, extended deadline. I believe I processed all that. Autolab should be up to date with AO1. You're worried about your interview with me? Don't be worried. Just study. So for those of you doing makeup interviews with me this week, so I'm doing a ton of interviews. For those of you who don't know, that's what I'm spending most of my time on right now. This week, next week, and finals week, it's my turn to do all the interviews for anybody who's missing learning objectives. So if you're doing an interview, with anyone, any TA, but obviously now I'm just noticing it a lot more because I'm doing so many interviews, please read these explain bullet points. I'm just shocked how many students come to an interview. It's not a huge number, but it's more than 0. Come into an interview with me, and they'll be like, okay, ready for LO2 interview. And I'm like, what's inheritance? And they're like deer in the headlights, like, I didn't know you were going to ask me that. It's like the first topic mentioned in the bullet point. It's been in the syllabus since day 1. How did you not know I was going to ask you that? Like, if you're preparing for an interview with me, please read this bullet point and understand the topics that I will ask you about. Like, we're not pulling any punches here. We're not tricking you or anything. It's been right here since day 1. This is what I need you to know. in order to prepare you for the next semester. If you can't even study that, and just study those things and talk to me about them on my interview. If you get tripped up on my follow-up questions where I try to dig deeper and make sure that you didn't just memorize a definition, that's another thing. But if you didn't even bother memorizing a definition, come on, work with me here. I'm trying to get everybody who's close to passing done with these interviews so they can get through. But you got to work with me. You got to study at least a good amount. Jesse's smiling and gives you a 0. I mean, I don't like. So I've been passing, most students have been passing interviews with me this week, but those, I don't even know how to react when I'm like, okay, LO2, what's inheritance? It's few students, but it's more than 0, and it gets me every time. What's up, Trino? All right, so let's do this. But those of you going in interviews with me, don't stress too much, but prepare. Read that bullet point and make sure that that you're ready for that. Right. So for GUIs in Scala, we use actually 2 libraries, ScalaFX and JavaFX. ScalaFX is an interface for JavaFX, so we're really only using JavaFX, but ScalaFX lets us use Scala features that we know and love with this Java library. JavaFX is built into Java, and this is why at the beginning of the semester your version for Java was so important, because in later versions of Java, I always forget which version, I want to say 11, but one of the versions of Java, they removed JavaFX and moved it to an external library, which, it for some reason is finicky with POM and Maven. I don't know. I got to look into it again and make it a little smoother so I can say, I think next semester I want to say use the latest versions of Java and Scala. But this is why we say Java 1.8, because Java 1.8 I know has JavaFX built into Java. We don't have to add it to our POM. Don't have to install it at all. It's just already there. ScalaFX does have to go in our POM. That is a separate library. It's not baked into Scala. So we have to use, we do have to add ScalaFX to the POM, which if you've been using the same POM from the examples repo, it's been there since day 1. Nothing to think about, nothing to worry about. It's already there, and when you import the stuff that we see today, it'll just be there already because you already ran Maven. I do recommend, if you're going to look on your own, I'll show you a few things about, just the basics of how to build a GUI that works and does a few things. If you want to know more, I do recommend looking at the JavaFX documentation, not the ScalaFX documentation. I think the ScalaFX documentation is poor, to say the least. Very missing a lot of detail, a lot of stuff that could be there. JavaFX documentation, on the other hand, is phenomenal. It's fantastic. So much detail, everything you would ever want to know. It is in Java, so you do have to convert that Java code into Scala code, which is surprisingly not all that tough. If you look at the class names and the method names and the variable names, you can just type the same thing, but using Scala syntax instead of Java syntax, and it'll do what you want to do. Like, for example, later we'll see rectangles and circles. If you want to add hexagons, I don't even know if that's a class in JavaFX. But if you find another class, just look at the variable names and the class names and do the same thing that we did with circles and rectangles, and you should be able to get on your feet pretty quick, even though that is Java code. Or you can pick up some Java. I always recommend, after taking 116, go study Java properly. Go find, not properly, but explicitly. Java syntax and Scala syntax is very similar. A little bit of differences, but it's not too hard to pick that up. Go to a website, read up on some Java. IntelliJ is built for Java. We just use a Scala extension to add Scala to it. So if you just create a Java class and start writing Java, IntelliJ is all set up to do that for you. Find a tutorial online and write, one of the programs that you've written for this class, write it in Java. It's a very good exercise, and if you can add Java to your resume, that looks fantastic. And if you can contribute Java to a company out there, that's fantastic too. What about C++? I have my feelings about C++, but more languages and more familiarity is not going to help. Is not going to hurt you. 250 is not in C++ anymore. 250 is in Scala now. 220 is in C, right? Like Do It Small says. Yeah, why is there nothing on ScalaFX out there? There's one tutorial, I believe I link it from the course website. There's one tutorial that, a YouTube playlist that goes really well through ScalaFX. Yeah, no more C++. I have my opinions, but really quickly, C++ doesn't have too many homes out there in industry anymore. You know, there are a lot of places that use it, but very few places where it is the best tool for the job. The one big industry that does use it is AAA gaming. They need both low-level control and high-level design, and that's where C++ shines. Most places don't do it, but for some reason, engineers love the language. If you take an engineering programming class, for some reason, they throw C++ at you like 100% of the time. I don't know why they love that language so much. I think I don't know. I gotta cut that one short. We don't have time. There's no time. So let's build a GUI. The example GUI we're going to build today is a degree converter, converting Fahrenheit to Celsius. So you type in your Fahrenheit degrees here, you click the button, you get the Celsius degrees here. Simple app. Functional wise, from a user perspective, very simple app. Let's see how to build this in Scala. Most AAA games are programmed in C++. If it's not a AAA game, if they're using Unity, probably C#. Java, I don't know. I wouldn't be surprised. I know Minecraft at least was in Java originally. I don't know if it still is with Microsoft taking over. But when you're at the AAA games, when your big selling point of your game is graphical fidelity and you have to get every ounce of power out of that graphics card, C++ shines there. Java is just with garbage collection and the like, it's just too slow. C#, same thing. C++ lets you control memory at a lower level, so you don't have garbage collection running on a frame and then dropping the next frame. You can't have those things. That you just can't do that and still call yourself the big AAA title that's coming out with, look at how the water moves and everything looks very pretty. You can't do that if your language isn't allowing you low-level control over the memory. Yeah, exactly. If you're not in AAA gaming, then whatever. You can code it in Python or whatever. It doesn't really matter. AAA gaming, graphics are so important that you need that level of control that C++ offers, or C. But C doesn't give you that high level, object-oriented hierarchy, type hierarchies and things like that C++ adds. So C++ has a good home in AAA gaming. I don't see that changing. That's the right language for that job. So to talk about this library and talk about GUIs, we're going to use a new concept, not a new concept, but new syntax called initializer blocks, which is a block of code that's executed as you create a new object. So when I create a new object, I'm going to put a block of code right after the constructor call. And that block of code is going to be executed inside the scope of this object that's being created. And I can run any kind of initialization code that I need. So for example, in this valid syntax, whenever we create a new object, if I create a new physics vector with 1, 2, 3, y being 2, and then I give it an initializer block and I say, no, never mind, y equals 10. When I get this vector here, I'm going to get 1, 10, 3. So it's any code that's executed. I can add any code to the creation of this object, so I can initialize whatever I want. We're going to use this extensively, and the documentation uses this extensively for ScalaFX because there are so many variables that we want to set, and sometimes we only want to set a few of them when we create an object of these types. So the alternative would be creating a parameter list that's like 20 parameters long. That would just be annoying. So the parameter list is nothing. There's no required parameters for most of the objects we'll create. And then you can create an initializer block to set only what you need for that particular instance. Happy there's no lecture question. Yeah, no lecture questions for a while. If I gave you a lecture question this late in the semester, you only have a week and a half if I gave one today to do that, and it just doesn't give you time to catch up. If you're already behind and I'm throwing you another one with a week and a half left and saying you have to complete it to pass the class, it's just too much. So no lecture questions for the last few weeks of the semester. So the basic structure, here's the absolute minimum to be able to get a GUI running and get a GUI showing up on our screen, is creating a class, an object that's going to extend JFX app. And JFX app is going to contain our main method that will have a main method in there that starts the program, runs everything up. So we don't have to create our own main method, but we do have to set whatever we need to be able to add our personal touches to the GUI, actually make this our GUI. So the primary thing that we need is the stage, which we're going to, I'm getting ahead of myself, ain't I? But the big thing is the stage. We're going to set the stage equal to all of the content that we want to display in our GUI. So first we need all our imports. We're going to import whatever we need. If you have that pom.xml from the examples repo and you ran Maven, you have ScalaFX installed and linked to your project. And you can start importing those classes and objects into your code. So we're going to extend JFX app and set the stage. Stage, that variable is inherited from JFX app, from JFX app, which should be an object. It would have to be an object, right? And then we're going to initialize that stage. We're going to set that stage equal to a new primary stage, and we're going to use this initializer block, this initializer code, to be able to set just the values we need. So primary stage has a lot of instance variables in it, and we only, for our purposes right now, only want to set 2 of those. So inside the initializer block, we're just going to set 2 of those variables: the title, which is going to show up in the title bar of the window, and the scene, which is going to be all of the contents of that window, everything that goes in it. We're just creating an empty scene here, but we'd create a new scene, use another initializer block. I told you we're going to use this extensively. We're going to end up with triply nested initializer blocks at the end of this. And we're going to use an initializer block to set the content of that scene, which takes a list of GUI elements, and all those GUI elements will show up in the window. So this is the basic structure. This is the basic template you would start with to create any ScalaFX app. You would take this code, name it whatever you want to name it, and start adding your GUI elements right here and change the title to whatever you want. Everything else, pretty much for any GUI you're going to make, would be the same. None of that will change. So let's start adding things to this. And for now, we want to add 2 text boxes, one that the user can edit and input the degrees in Fahrenheit, and one that the user cannot edit, which is going to be the output of the degrees in Celsius. So first, we need to import all of anything that we're going to use, all our objects and classes that we'll use for this, and these have to be imported from ScalaFX. JavaFX is going to have many of the same classes and objects of the same names and the same package structure and everything. So it's very important that we make sure that we're adding the ScalaFX versions and not the JavaFX versions, with only one exception that we'll talk about later, where we will import a JavaFX class, but everything else should be ScalaFX. When you do auto import, or if you just type things and you like IntelliJ doing all your imports for you, IntelliJ will often import the JavaFX. So this is one case where you have to be very careful about what's being imported and not just using the auto import options and letting the IDE take care of everything for you. You do have to watch this a little bit. If you start getting really weird errors with your GUIs, one of the first things to check is your imports and making sure you're using the right library. Because if you start mixing the libraries in unexpected ways, things are going to start breaking. Are we going to... what do you mean by that, Kylens? Are we going to review those in 300 plus courses? the languages that we were talking about. We don't. If you're talking about the languages, I believe Java shows up in 305. It doesn't show up anywhere on the required path. If you're only taking the required courses, you might not encounter either Java or C++ anymore. You used to take both of them by your third semester. We used to cover both of them. I'm not aware of any courses that are still covering C++. You get a lot of C, but not C++. And Java, I think, still shows up from time to time as like an optional language. Some classes have options where you can use one of 3 languages, and then you just choose the language that you like the most. And Java is usually on that list still, just because we used to have Java as a big part of the course. Yeah, soft top. Yeah, and they teach Java for the AP exam, so a lot of you have Java experience, and then you can't really take advantage of that too much in our curriculum. Yeah, that's one thing that's sad with the curriculum redesign. There's no required Java or C++, which are still 2 big languages out there. Java more so than C++. How much GUI stuff is taught in later classes? I don't think much. The problem with teaching GUIs is there's really nothing there. There's no new concepts to teach with GUI stuff. It's all syntax. With what I covered today, you'll be able to go through libraries, read documentation, and nothing should really catch you off guard. You know all the concepts behind GUIs. Like, it's a combination of OOP and event-based architectures. Maybe a little FP. I think we use a little FP syntax in here. So you already know all the concepts behind a GUI. Today is really just talking about the syntax, which doesn't make for a really compelling lecture if we're not really teaching you something new. So, but it is interesting because you get to build stuff that, you actually get to see your programs. So, once we have those imported, it's time to create our text fields. So, SkyFX, JavaFX does have 3D capabilities. You can do 3D graphics with this library. I won't cover it in class, but certainly something you can do. Then you got to worry about cameras and camera angles and rotations and stuff. It's fun stuff, but it's a bit beyond the scope of what we want to talk about. Because again, it's syntax and learning the library, no new concepts, really. Except game design concepts, I guess. Anyway, so we create new 2 text fields. Maybe that would make a good... when I first redesigned this course for adding Scala and everything, I did want to have a 3D GUI as a semester long project, but there's just too much there that's not related to the course content. So we create our 2 text fields. We're going to use this initialization code again. We're going to use the text field class from the SkyFX library, and we're going to set whatever variables we need to get the look and feel that we're after. So one of those things is the style. If we want to change the font here, which I'm going to change to 18-point Arial for whatever reason, it's just what I wanted, I guess. If we want to change anything with the font, we can set it here. And with the output text field, I'm not going to let users edit that, so I'm going to set editable to false. So you can't change the contents of this. So you just can't change the output field. Then I'm going to add these. I'm not going to add them directly to my content, which I don't believe I ever do in any of my examples. I'm never going to add that or any of the GUIs. Obviously, you can look through all the GUIs for the homework assignments to see more examples of these if you haven't already. But I'll never add something directly to the content. I'll add some container and then add that container to the content. In this case, I'm going to use a vertical box, which is going to control how the elements are organized in the GUI. So here I want I want these displays organized vertically. So the input box, the first element in this list, is going to be on the top of the GUI, and the second element, this output display, is going to be below that. So they're going to be arranged vertically in the order in which I provide them in this list, in this children variable, again using this initializer code. Told you we're going to use that extensively. The constructors are usually empty. These parentheses, I believe, are optional, and I could add parentheses here. I mixed them there, but the initializer code set whatever we need. In this case, the children, which is going to be a list of all the elements that should appear vertically in this container, and then that container goes into the stage, and then the container goes into the stage. So we can, since vertical box extends jfxs.node, which many different containers, there's a lot of different containers to choose from. You can look at the calculator or microwave assignment to see usage of a grid system, where I arrange those buttons on a grid so they're always displaying in the way that I want to. Anyone who did the calculator expansion knows about that. You had to go into that grid and actually extend it and add another row or column to get your new buttons on there. HBox as well. If you want them organized horizontally, you would use HBox and you get everything horizontally. And you can even nest them. You can have a VBox of HBoxes to get somewhat of a grid, or you can use explicitly the grid, like I used in the calculator and microwave. So I added the vertical box. The vertical box has a list of elements, so now these are displayed vertically. So all that to get these displayed the way that we want them to be displayed. And anyone who's worked with GUIs, if you worked with web front ends, for example, getting the elements where you want them to be can be quite difficult. So I think this is kind of a relief that it's fairly straightforward. I want these vertically. I create a VBox and it's done. Those are going to be vertical. To get the specific look and feel takes a while, like just getting the calculator buttons created in a way that there's no gaps between the buttons took me way long to do. So getting things just looking just right, like this doesn't look great, but I just wanted it to be done. But to get this looking better, takes a good amount of effort. So let's add a button to this thing. Same thing, new button, initializer block of code. And I'm going to set a few things here, the min width and min height, to be able to get the size of the button proper. I want this to be a square. If you don't set these, the size will be determined by the font that you have. So I made this a little bit bigger than what my text is going to take up with this font. So I know that I'm going to get, a square button. I just wanted a square button here. If I didn't, I could set the width a little bigger. I could set the width to the width of this window. We can play around with that. The style, I want a bigger font here. And then the text that's going to appear on the button. And then I'm going to add that button wherever I want it to appear vertically on this GUI. So I want it to appear right in between the two text fields. So I put it right in between, and it's going to show up right in between vertically with no gaps in between here. I believe vertical box has a gap or a padding variable if you want to space those out a little bit. I kind of like them right on top of each other, at least for the apps that I'm going to show. Yeah. I've wasted so much time trying to get CSS to do what I want. Trying to get CSS, for some reason, every single time, I still haven't figured this one out, but CSS trying to get something to be centered vertically, I don't know, I could just never figure it out. Everything the internet tells me, like, oh, just do this. I do that, and then it doesn't work, like, ever. So I created the button, added the button, and everything is here. We have our GUI. We're done. All right. We can go home now. But not quite, because this button doesn't do anything. So how do we get this button to do something, to be able to actually react when the user clicks it? So the user clicks, that's some event. We want to use our event-based architectures to react to that event and run whatever code we want to run. So for that, button has another variable called onAction, which takes an event handler of an action event as its type. And we need to give it one of those event handlers of action event. So when the button is pressed, an action event is created with all the information about this event that just occurred. The event being the button click. The user clicked this button. So that action event is created, and it's passed to this event handler of type action event, and then that action listener, that event handler is going to handle that event. So whatever code we want to be called when on action occurs, when this button is pressed, is going to be handled by this event handler. And this event handler is going to have to read from the input display and write to the output display. So I'm also going to pass it references to both the input and output display. So now let's actually see what this button listener is. This is a class that I created. There's no button listener in the library. So when I created this class, I created a new class. I named it button listener, and I had it take those two text fields, the input and output. So I have to have parameters for the constructor to be able to take the input and output text fields so it can read and write the values for that. And I have to extend event handler of action event because that's what the type is of that on action for the button. And this is that one case, you're right, RT Keenan, this is the one case where we have to use JavaFX. This event handler, action event, and anything else related to events in our GUIs when we're using ScalaFX, anything related to the events has to be from the JavaFX library. There are ScalaFX versions of action event and event handler, and if you use those, things break, and it's no fun. I went down that road. It sucks. Don't make the same mistake I did. So I'm warning you right now from my experience. The event stuff has to be JavaFX. I don't know why. It's a ScalaFX button, but it uses a JavaFX event handler of a JavaFX action event. So we have to extend event handler. We extend event handler of action event. So event handler has a type parameter, which we're going to give it action event so it works with our button. Buttons react to actions, action events. And then we have to override its handle method, which has to take the type parameter, which is action event here. So this is the method that's called whenever that button is clicked. Whenever a button within a button listener, this button listener attached to it is clicked, we're going to call action event, handle with the action event of that button press. And we're going to run whatever code we want. For our purposes, we want to read from the input display. The syntax for that is .text.value. And we want to write to the output display. Again, .text.value. And set it. This syntax here, I'm rounding to 2 decimal places. So we don't have truncation errors and the like. And if it's 0.55555 or whatever, we don't have things like that. I'm just going to round to 2 decimal places. And since this is a class, we're creating a whole new class. We have to implement handle because that's an abstract method from the event handler class. But we can do anything else we want with classes. We already created a constructor to add a little more functionality here, but we can also create helper methods. I have this helper method here just to reduce clutter from the handle method. I don't want to put too much, I don't want to mix my logic and my math with my handling of GUI elements here. So I defer to this method to do all the calculations, and then I have this handle method just interacting with the GUI elements. And whenever we want a button to act like this, we just instantiate it. Yeah, it's not regex, it's formatting syntax. It's a whole different thing. But it has its own syntax to be able to format numbers however you want and other strings. So our degree converter is complete. Yay! So this does things, of course, button listener in a different class, and I remove the imports just to reduce clutter. Looks like I could have fit them all on this slide. But that's our degree converter. So we have a full functioning GUI. We use a lot of object-oriented programming, a lot of objects, a lot of inheritance going on here. I guess not a lot explicitly, but the button listener did use inheritance. And also event-based architectures. We have this button that reacts to the event of being pressed and defers to a handler, which has code that's executed when that button is pressed. So with GUIs, we naturally have event-based architectures where every event is an action taken by the user. If the user types in this text box, that's also an event, and the text field is going to handle that. The text field already has its event-based architecture built into it to react to the event of a user typing. And a user can click on this box. A user can highlight this and be typing at the same time that they click on the box. We have multiple things happening concurrently. We have all that event-based architecture goodness going on whenever we have a GUI. GUIs are naturally event-based, where the events are user actions. So that's cool and all. But what about graphics? Maybe we want something you can imagine, I'm sure, a GUI that's not just buttons and text fields and text boxes. And by the way, we can add like radio buttons and checkboxes, drop-down menus. All that stuff exists in this library. We can just add them the same way. The syntax is no different. I don't see the point in just going through each of those one by one. You got the documentation. You're fully capable of reading the documentation and just figuring out, oh, I can say new text area, and then it gives me a bigger block, and I can set the size of it and stuff. But you got the concept down of how to do this. Now let's talk about the concept of graphics, in 2D graphics specifically. I know y'all want it, but we won't get to 3D graphics. Let's put it on a server and multiple people can use it at once. Are you talking about this example? Yeah, it's so that's what we did with the chat app. The chat app had a desktop GUI. I didn't talk about the GUI itself, but that's exactly what we did. Everybody runs the GUI, and that GUI sends events to the server. So the GUI receives user actions, user events, and in reaction to those events would send the event to the server, and then the server would react to that event and then blast that new chat message to all of the users. Those GUIs would react to that event, display that, and add it to the chat history and everything. We exactly did do that. You have everything. By the way, you do have everything that you need to. We'll see an example explicitly on Friday, but you do have everything you need to build an MMO. We did get there. We have all the things that you need for that. All the technology. Actually building the thing and making a fun experience. That's a lot. But you have all the concepts and knowledge to be able to do it. So go build MMOs. I want to see all your cool stuff. I used to require it as a semester-long group project, but it just never worked. Never worked the way I wanted it to. So let's talk about graphics. I have some notes on here that don't really apply anymore. You don't have to use any graphics for any of your projects. We don't have that semester-long group project anymore. It was more of a distraction. Now it's just an exercise in Git, basically. So this doesn't really apply, but if I did ask you to write GUI code, I would not grade you on the graphical fidelity of it, for what it's worth. This is something that's already affected you, and I wish I did at least go through this slide earlier when we talked about GUIs or when I was going to talk about GUIs during Makeup Week, because this has affected you in Maze Solver, where the coordinate system, when we talk about graphics, the upper left corner is always 0, 0. So the y-axis is inverted. This is just the way things work. Your monitor that you're looking at right now, the upper left corner is 0, 0. And the bottom right corner, that's the size of your screen, the maximum X, maximum Y. So whenever Y increases, you're actually moving down your screen. So the Maze Solver, the maps for that, use this coordinate system where the upper left corner is 0, 0. And those of you who had bugs where you would fire up the GUI and your avatar would immediately go up to the upper left corner, it's because, at least the one that I really dug into the code to find out why, it's because when you first start it up, your path is the empty list, and that's an edge case that's not defined in the documentation that I give you. I don't say what should happen when you're trying to get the velocity when the input is an empty list. And if you're navigating towards 0, 0, it's because you initialize your path, your character, to move towards 0, 0, and then iterated over the path and figured out where to actually move. If there is no path, you just default to moving towards 0, 0, and you would just automatically go up here. I'll add to the documentation next semester. Right now I have assumed that your character is on the path. I'm going to change that to say if the path is empty, don't move at all. Velocity should be 0, 0. If the path is non-empty, then you can assume it's on the path. But little thing. But anyway, that's why some of you saw your character moving towards the upper left corner. It's because that's 0, 0. X goes this way as you would expect, and Y goes down as you might not expect, as you're not used to. But that is standard. That's common. Images too, coordinate systems for pixels on an image, same thing. Whenever we're talking about graphics in a computer, 0, 0 is the upper left corner. So it's a big thing. Just get that in your head. It takes a while to get it accustomed to. It took me forever to adjust to it, inverting this y-axis. But that's the reality. That's why things are. Don't ask me why. I believe it's something to do with refresh rates. When the screen is redrawn, I believe it just starts at the upper left corner instead of the lower left. Anyway, let's get on with it. So we're going to add a few shapes. I'm just going to show you 2 shapes. And again, the syntax for other shapes, it's going to be similar. So we'll just use these 2 as examples. Any circle or rectangle. And there just happens to be classes named circle and rectangle. So we create new circle and rectangle and then use Initializer Code to set whatever values we want to be able to control the look of these objects. So for a circle, this is defined by the location of the center of the circle, starting at the upper left corner. Remember Y, so as Y increases, we're moving that circle down the screen, and the radius to control how big this circle should be. And I also want to change the color. I'm going to change the color to green. I'm going to use the color class, which has constants for common colors, or you can use RGB values. There's a way to do that in the library as well. So I'm going to set the color and the location and the size. Rectangle, a little bit different. We use translate X and Y to set the location of the upper left corner of the rectangle, and then the width and height to control the size of the rectangle. So we start at the upper left corner of our screen. We're going to go, I might as well actually do it, 60 to the right, 10 down, and then draw a 60 by 40 rectangle at that location, with that as the upper left corner of the rectangle. So a little bit different. The location here is the center of the circle. The location here is not the center of the rectangle. So there's a little math to do. If you have the center of where you want a rectangle, you do have to do a little math to get the translate width and height exactly the way you want it. To get your center, translate X would be the center minus half of the width to get that where you want it to be. Translate Y is the center minus half of the height to get it where you want it to go. So we're going to add these to our scene, and we're not going to use boxes like we did before because it doesn't make sense to organize these shapes vertically or horizontally or on a grid or anything. Each shape is going to know its exact location based on its center XY, translate XY, width, height, radius. These graphics are going to know exactly where they're supposed to be. So we're going to use a more generic structure, just a group. Throw all these shapes in the group by adding it to the children, and then throw that group in the scene. And then the shapes themselves control where they actually end up rendering. Yeah, RGB, it's red, green, blue from 0 to 255 for each value. So if you have like 0, 255, 0, that's going to be green. Is it hard to implement custom shapes? I don't know. I haven't tried, to be honest. It's easy to add custom images. Like if you have an image and you just want to use that as your avatar, it's super easy to insert art assets. But if you want to draw using this library, I'm not sure what that looks like. I haven't tried that. I would just draw using a different program and then import the graphics. Export them as GIFs or JPEGs or whatever. It'd probably be the easier way to do it. So here's our full example of a 2D graphics GUI, which has a few things that I haven't talked about yet. So let's discuss those. So for this, for our first example of the degree converter, the size of the window was controlled by the size of the elements. So the max width element, that controlled the width of the window, and the total height of all the elements, that controlled the height of the window. And then the window shrunk to be as small as it possibly could without interfering with any of the elements that we added to the scene. We don't really have that same feature here because these shapes can be any sizes, and they could potentially, ideally, move around. So we're going to explicitly set the window height and width, and then give those to the scene when we create this new scene. And we're going to use those as constructor parameters. We could also do it in the initializer code, but since these are two optional parameters in the constructor, we're going to do it that way. And also, I'm going to create a method. No, not a method. I'm going to create a new circle for the player, but at a random location on the screen. So when I fire up this GUI, my player starts in just some random location. I get a random value from 0 to 1, and then scale it by the width, and then another random value 0 to 1, scale it by the height, and make a green circle. And if we want things to move around, which we often do in a graphical GUI, we can use what's called an action timer in our code, where we're going to give it a function. So this is where we use the FP. I knew that. A function that takes a long and returns nothing, and the long is a timestamp for, just like you're using for clicker, is a timestamp of the current time. This is going to be called 60 times per second if it can. So the ScalaFX and JavaFX, these libraries, are built to work at 60 FPS, and you can't really change that. So when we had actors, we could control the frame rate. With these libraries, we're stuck with 60 frames per second. That's all. That's what we have. That's what we have to work with. So this is called 60 frames per second. So action timer is going to call update 60 times per second if it can. If it gets bogged down, if the CPU is burning up or something, we might start dropping frames. But it's going to try to run 60 frames per second, and it's going to give us the current timestamp so we can work with that time. So maybe we did drop a frame. We want to make sure we're working off this timestamp to process 2 frames worth of movement. I'm actually not using the timestamp for this example. I'm just going to rotate every rectangle by half a degree. So by changing their rotation value. You have to change the canvas size. Oh, you're answering someone else. Yeah, if you change the size of the thing, you gotta change some JavaScript as well. Yeah, Juicy's got you. Can add points on the circle. I would assume that there's a polygon class, but I haven't worked with it. I haven't used it. Usually when I'm doing graphics, I'm doing it in JavaScript. I'm using those libraries. Because desktop GUIs, like, what do you really do with them these days? One of the only desktop GUIs I use these days, well, I shouldn't say that, but the one I use the most is a web browser. And then the web browser renders my web GUIs. Oh, yeah, and video games, if you want to make a game. Oh, yeah, right. If you want to make a game that's not in the browser. Yeah, I suppose. That makes sense. It makes too much sense, actually. All right, so good thing I've covered this anyway. So graphics are cool, great, but nothing moves around. We have this. We can make rectangles that spin like I did here, and we can react to time. And we could use this to build a clicker game, an offline clicker game. That's just a Scala game. But let's do something a little more interesting here. Let's react to mouse clicks. And I'm a little bit in the way here. But in the scene, we can add event handlers to the scene. Give it the type of event we're going to react to. This is very similar. This better sounds similar to the past 2 weeks of content that I've covered. We're going to listen to the event type. In this case, I'm going to listen for mouse clicks. And I'm going to give it a handler that's going to handle that event of mouse clicks. And I'm going to create that handler class. Mouse event handler is not part of the library. That's something I defined. Mouse event handler, which is going to extend event handler of mouse event. So this is going to take an event handler of the type of event that I'm listening to. And it's going to give it a mouse event when it handles that event, but I only want this to react to mouse clicks. So there's different types of mouse events. There's mouse down, mouse up, mouse scroll, left click, right click. I'm going to listen for every click of the mouse, and every time the mouse is clicked, this handle event is called. And I believe click happens when you release the mouse, if I'm not mistaken. I always get mixed up on the difference between mouse button release, releasing the button, and clicking the button. But I'm going to listen for mouse clicks. And this method is going to be called every time a mouse is clicked. And I'm going to draw a rectangle with this method. This is where I'm going to shift. I know where my center is. I want the center to be where the user clicked. And I'm going to shift that by half the width and half the height to get my translation to where I want it to be. And then I'm going to get information out of this event. So last time when we handled an event, we didn't use any information of the actual event. The event was a button click, so a button press, so it was whatever. The button was pressed. I don't need any extra information. Here I actually want to know where the mouse was pressed. So I'm going to get the information out of this mouse event. I'm going to get the X and Y locations of that mouse event, which is going to be the location on that window. Where on that window was this pressed? So I can add a rectangle to that exact location. I'm going to add it to the I have to cheat. I'm going to add it to the group that's holding all my graphics, and I'm going to add that to a data structure containing all my rectangles, so it's going to spin. So when I iterate over all these rectangles, that rectangle is going to spin. And hopefully by this time, this is sounding very familiar. This is the GUI that I had you run in week 2 in that lab, where that you had to demo to your TAs, where you can click around and create these spinning blue rectangles. It's a super fun game, if you can call it a game, which you can't. But we're going to add it to those 2 data structures. This one so they display on the GUI, and this one so my action timer is going to update those rectangles and rotate them. So we get rotating rectangles. Not super interesting, but this does act as a proof of concept that we are both reacting to user events and modifying the graphics based on that event, and also having those objects react, do something over time. So maybe we want this to create, whenever you click, it creates a ball that reacts to gravity, and you plug in your physics engine from homework 1 into that to be able to get the physics of that. We can do all that here. You can combine this with what you know from the rest of the course and build some really cool stuff. You can get some cool stuff going here. But this is a proof of concept. You can react to user events and have those objects move over time. You can have them animate. Oops, I went through this whole thing without ignoring my slides. So when we first talked about this, we didn't have any rectangles, but as soon as you start clicking, you get those rectangles. They start spinning at half a degree per 60th of a second, so 30 degrees per second. And everything... Oh, I forgot I had this. Let's... I'll cover this. I'll still talk about this in a little bit of overtime, but I do want to run that GUI. You've all seen it run, but now that we've really talked about it... Oh, shoot. I don't have the right, I have the right one open. I'm on the wrong screen. Okay, there we go. So here's that GUI. Let's run it. You've seen it run on week 2. We get to see it run again on week 13. But now you know exactly how to build this thing. Speedrun of coding among us. And I click, and rectangles that rotate at 30 degrees per second. Woo-wee. And the last thing on this GUI that I'll talk about in a little bit of overtime here is when I use WASD, I can move around. This is probably something that most of you didn't realize in week 2, but you can move around this circle too. So this is your player, So I can both react to mouse clicks and keyboard events. And of course I can do them both at the same time. So this GUI is reacting to both of those events concurrently, which with event-based architectures, we get this concurrently running code. Of course, what we want, the user can do two things. You can use the keyboard and the mouse at the same time. That's something you expect from most of your games. Most games you play, you want to use both. So we can react to the mouse. If we want to update the controls and have the mouse control where you're looking and the keyboard control where you're moving, you can absolutely do that. So let's go back to our slides and finish up how we get that keyboard to work. And hopefully you know where this is going. We're going to create an event handler that handles key events instead of mouse events. One line away from Battlefield 5. Yeah, we're almost there. I mean, if you rewrite this in C++, it'll basically be Battlefield 5. So we're going to listen for key pressed events. This, again, there's key down, key up, key pressed. So we're going to listen to those events. And whenever a key is pressed, we're going to send it to our key event handler, which is a class I write, which is going to extend event handler of key event. And handle is going to take a key event, which has a code, which is going to be a code that tells you which key was pressed. I'm going to send that code over, again, separating my logic from my GUI stuff. I'm going to send that to this key pressed method, give it the key code, get the name of the key code, and depending on which key was actually pressed, I'm going to behave differently. If it was W, I'm going to decrease the Y of the player. It should say player location. This code might be from a different program where I was doing speed, right? No, that doesn't make sense. No, I'm just reading this wrong because I'm crazy. So every time the key is pressed, we're going to decrease its translation by its speed. So its speed is how much the player is going to move with each key press. And if you hold down a key, like I was holding down the key earlier, it's going to move the player once. It's going to trigger a key event once. It's going to have a delay, which is usually, I think, about half a second. And then it's going to keep sending the key pressed event. It's going to keep triggering the key pressed event as long as that key is held at some certain rate. I want to say like 10 times a second or something, but we will get that key pressed event continually called as you hold down a button. If you don't want that action, you can react to key down and key up and keep track of whether the key's up or down. Much like we did in the jumper app, we didn't rely on key pressed. We relied on, are you currently holding it down or not? And then we handled that in our code. We decided, okay, we know you're holding it down, so we want to keep moving you in that direction. But here I'm doing a more simple thing. I'm just saying we're going to take the key pressed event directly and then just move you based on that. If you press some other button, you're going to get, nothing's going to happen. For Control C and Control V, yeah, you'd have to do some extra logic here, but you can do the same thing. I believe the event has like dot is control being held down. Don't quote me on that. I could be wrong, but I believe the key event has that information of whether Control, Alt, Shift are being held. And we've seen match case before, so I don't have to re-talk about this. But match case to be able to control. Usually we use this to change behavior based on type. Here we're changing the behavior based on the value. So we're not adding any types here. We're not saying case S of type string, then do this. We're saying what the actual value is of that string. Or if it's not a string, if somehow getName didn't return a string for whatever reason, or if that string was not WAS or D, which can happen a lot.